So in this video, we are going to see deletion at the front end in a double-ended queue, that is Deque. So algorithm is given here. So this is example we are going to see. So what is the first step in every deletion? Whatever the deletion cases, we have to check it out whether it is having at least one element in the particular data structure. So here, as far as the queue is concerned, the queue must have at least one element. Then only we are able to execute the delete element. Whether it is a front end deletion or it is a back end deletion, rear end deletion. So we first check it out whether the queue is having some element or not. If the queue is empty, we are unable to take any element. We are unable to delete any element. So that's why the very first condition is if front equal to -1 and the rear equal to -1. It means that this is the scenario. So in this scenario, what is it? Already front and rear is in the -1 case. -1 it is nothing but there is no element in the particular queue. Okay. So usually the queue which is represented as 0, 1, 2, 3, 4. Okay. So here what is n value? N equal to 5. Okay. So this case, this is the underflow condition. Underflow does nothing but there is no element to delete. So that's why already it is empty. So that's why it is called as underflow condition. Go to step 3. It is we exit the process without doing anything. Otherwise, if the front is not -1 or rear is not -1, then I come here for executing step 2. In step 2, what we are doing, there are three cases of that. The first case is if front equal to 0 and rear equal to 0. So this is the condition. What is it? Front and rear points the same element because only one element is there in the queue. So in that case, we are executing. How can we execute? Value equal to q of front. We are taking the according to the front pointer. Why we are concentrating front pointer? So we are executing deletion at the front end. So that's why we are concentrating front pointer. According to that front pointer, we are taking the information and put it in the variable called value. So after deleting that, we have to reassign the pointers. Okay. So only one value is there. After taking that value, so what is it? The queue is empty. So that's why set front equal to rear equal to -1. So in this case, what we do? Front, rear comes here after deleting that. This is the first case. And the second case is, suppose the first case is not satisfied, we come to the second case, else if front equal to n-1. What is that? This is the scenario. Front equal to n-1 means it is in the last position. n-1 it is nothing but 0, 1, 2, 3, 4. It is the fourth position. If it is n-1, we are taking the value according to the front pointer, value equal to q of front. After that, set front equal to 0. What is it? After taking this front value, we are reassigning the front pointer from n-1 last array to first array because it is a double-ended queue. So that's why automatically the front pointer, it comes to the first location, that is 0th location. So as per this queue, it comes to the 0th location. So that's why if this condition is true, set front equal to 0. Okay. So this is the second case. So these are all the, what is it? Abnormal cases. In the normal cases, then if this is not satisfied, the above cases are not satisfied, it is a normal process. In a normal process, front equal to front plus 1. What is it? We are deleting the element. After deleting the element, suppose we are taking this case. In this case, suppose I am deleting number 5. I am taking the value from that. What I do? I have to, what we do, we have to, before that, I have to add one more information, value equal to q of front. After taking the value, after taking the q front pointer value to the variable value, after that we are giving front equal to front plus 1. After taking this, front pointer is incremented by 1. So this is the normal case. Okay. So through this way, we are executing the deletion at the front in a double-ended queue. So this is the simple logic. If you understand this logic, maybe so you are able to complete the execution of double-ended queue deletion at the front. I hope you understand this. So in this video, we are going to see deletion at the rear end in a double-ended queue. It is called as DQ. So the algorithm is given. All the possibilities are also discussed in this algorithm. First one is if front equal to -1 and rear equal to -1. So it is a usual case. Why you are checking this condition means whenever the queue is empty, we are unable to delete any item. So that's why just the condition satisfies front equal to -1 and rear equal to -1 means right under flow, go to step 3. We are unable to delete anything from the empty queue. Okay. So if this is not satisfied, the control comes here. If front equal to 0 and rear equal to 0, what execution we are going to do means we are going to delete one element instead of rear end. Okay. So at that situation, front equal to 0 and rear equal to 0 means, so this is the scenario. Okay. What is that? Front and rear points one element. It is the only element in the queue. Okay. So after deleting that element, what is it? Value equal to q of rear. So after deleting this, what happened? It is empty. So that's why set front equal to rear equal to -1. So automatically front and rear comes here. The value of both the front and rear pointer is -1. Suppose this is not the condition, front is not 0 or rear is not equal to 0 means the control comes here. So the second condition is else if rear equal to n-1. So this is the scenario. Rear is in n-1 position. So at the time what I am going to do, I am going to delete that item. So after deleting item, what is it? Rear have to come to the 0th position. So that's why after deleting that q of rear equal to value, I am taking the value from the q to end. I am storing the value in the value variable. After that set rear equal to 0. So rear comes here in the 0th position. Okay. So because what is it? It is a double-ended circular queue. And if these cases are not occurred, then we come to the normal execution. So in the else part, we come else means normal execution. Normal execution, it is nothing but value equal to q of rear. So this is the condition. Suppose this is normal. So what is it? We are taking 16 out. After that, set rear equal to rear -1. So what is the condition? 0, 1, 2, 3, 4, which is there in the 4th position. Instead, I am decrementing the rear value by 1. It goes to the 3rd position. Okay, because I am deleting this value. So these are all the possibilities when we are deleting one element from the rear end in a double-ended queue. Thank you.